Good evening, everyone, and welcome to this evening's webinar. My name is Dave Ludgate. I'm Chair of the Water Environment Society, and I'm delighted to welcome Julian Beatty with us today. The title of Julian's presentation is Advanced Water Filtration Solutions, Integrating Flocell XFM Fines Media Filtration and Puragen PFAS Treatment. So the webinar will feature Julian, who will detail the two technology developments for water purification. The first half will focus on Flocell XFM fines media filters, which are proven to be an effective low maintenance replacement for conventional sand and cloth filters. And then in the second half, Julian will cover developments in Puragen Activated Carbon for PFAS removal, a comprehensive solution for per and polyfluoroalkyl substances, or PFAS. This system not only achieves high efficiency PFAS capture, but also utilizes a unique destruction process through the reactivation and recycling of the activated carbon, offering a sustainable full circle approach to managing and destroying this persistent contaminant. Just a few housekeeping rules. This meeting is being recorded for publication later on the website. By all means, if you have any questions for Julian throughout the presentation or at the end, please put them into the Q&A tab at the bottom of your screen, and we'll put them to Julian at the end of his presentation. The question and answer section will not be recorded. So Julian is Managing Director of NovaQ Limited. Julian has extensive experience in sustainable water and wastewater treatment technologies. His expertise includes biological wastewater treatment, advanced filtration, and contaminant removal, specifically implementing the two technologies that will be covered this evening. He is currently spearheading the expansion of these proven technologies in Ireland for utility and industrial applications. So with that, Julian, I'll hand over to you.
Great, Dave. Thank you very much, and thanks for inviting us along to speak this evening, and thanks to everybody for showing the interest. For those that don't know us, NovaQ, I've been around now for 17 years, operating in Ireland and across Europe. Water, wastewater, aquaculture, which is obviously very closely aligned, and then in businesses in agriculture and renewables. But today, obviously, for the Water and Environmental Society of Engineers Ireland, we're going to focus on just a couple of kind of recent developments and innovations in terms of the wastewater side of things. Some of its innovations, some of it's kind of addressing emerging challenges. I think that the PFAS side of things is probably a scary area for a lot of people, and the fines filtration is very closely aligned. It works very well with the activated carbon part of the PFAS removal. So there's a logic to them all. The third area where we're very active is with biological wastewater treatment, but that's for another day. So I'm going to start off on the Flocell XFM filters. Some of you may or may not have seen these at the recent water and wastewater exhibition, or at at various other water shows that have been on. They're a relatively new concept, and as opposed to, I suppose, if you're looking in the space of fines filtration, you're comparing it to sand filters, cloth filters, all of that kind of area. Key with these is that they're, as a media filter and an upward flow filter, you're dealing with totally different pressures to those that you have in sand filters and cloth filters. And so it's probably better to say that the contaminants are retained rather than the filter acting as a barrier. And that kind of description is important. And the relevance of it really is tied down. It relates to these specific media that they have, which, I mean, I'm not sure if anyone can see what my hand or whatever on the screen, but that's the media itself is really very, very small inside the filters, and in each filter there's about 1,200 liters, and there's about a meter cubed of plastic media within that. The key features, the key benefit is, for sand filters and cloth filters, they very quickly have a hydraulic loss. With the open cell media, you don't have the hydraulic, there's very, very little hydraulic resistance. And ironically, the dirtier the filter gets, the better it actually performs, because the biofilm itself that might build up on the media enhances the mechanical filtration properties. So we're targeting suspended solids, phosphorus, iron, BOD, COD reduction, and so on. So just to give, I've got a couple of quick videos here now, which will kind of illustrate the how these filters work relative, in this case, relative to a sand filter. Importantly, these filters have got about 100 times more retention capacity than sand filters and cloth filters. Your conventional filter is top down. The water is coming down through the sand, and the solids are built up in the top of the sand. But as the solids build up, they cause a barrier within their own right, making the hydraulic properties much more difficult. That means more energy needed. With the media filters, the water is going up through the filter, and the media itself is buoyant. And so it's actually gravity that's retaining the solids within the media. So it can last an awful lot longer without having to be cleaned or backwashed. The backwashing is very different as well, and I'll go into that in a second. But basically what you're looking at is the solids here. They're retained in the media by the resistance of the media, and even part of that is a bit of a lamella effect within the media itself. And this is all certified by Cranfield, and his paper's available. For the backwashing of a sand filter, you reverse the flow, the water comes up from the bottom, it raises the sand and it lifts the solids, but you use a lot of water in the process of backwashing. With the XFM filters, we use a patented air process where we stop the flow, we turn on the blower, and the blower moves all the media and dislodges all the solids off the media. And there we then just drain the tank. So your total amount of water lost in a backwash is one fill of water, which is about 1,000 liters per filter. To see this visually, again, anyone who's been at the exhibitions will have actually seen this unit. It's our demo unit in play. You can see here as the water rises, the plastic media then is as it's buoyant, it stays up at the water level, comes up to the top of the filter. The dirty water there, you can see there's a whole lot of particulates and everything in this case. It gets up to the top of the filter, and you'll see in a second the clean water coming out the top of the filter, and the solids are retained then below the media. And over time, what happens is the solids then you see building up within the media. So it's just getting dirtier and dirtier within this media section. When it's ready to do the backwash, you turn off the flow, you turn on the air, and it literally, it's like turning it into a washing machine. So it just, the air dislodges all of the dirt off the media. You'll see the media now getting really active. And what you have is dirty water. So the vigorous agitation cleans it. This only goes on for a couple of minutes. You then stop the agitation and you drain the tank to the sludge outlet. So that dirty water, that's simply your discharge. We've had solid retention in that up to about 2.5% solids. So you are genuinely getting a really good sludge within that. So it's a far higher capacity than you'd have with a sand filter and so forth. When the filter's empty, then you just close your sludge line and you turn it back into flow mode, and you see here the water starting to build up again. And when the water gets up, it just lifts the media, and the whole process starts all over again. So it's a very efficient system using very little backwash water, and it's and very little human intervention. I mean, we've got a system here that has replaced two sand filters. The sand filters were being backwashed on a daily basis. The XFM filter is now being backwashed about every 3 weeks, just once every 3 weeks. So it really is very, very efficient in that regard. So the units themselves, they come now in containerized options. Each containerized option goes 5, 10, 20, and 40 liters per second is the flow capacity. Simple containerized units. I've quite a lot of information on these slides, which I'm not going to go through. It's really for the purpose for people coming back afterwards to be able to see it. So the XFM5, the XFM10, XFM20, and the XFM40. So you get 140 cubic meters an hour of flow through one of these units, and they literally arrive plug and play, ready to be used. There's a few site examples coming up here. In the UK, the first one here, this is an Anglian water site where the XFM filters are being used for water recovery. There's a Severn Trent site. This is a Yorkshire water site where the water is being balanced in here and the filter is doing dialysis on this balanced tank of water. This is one of the trial units in the UK, along with in England they've got a mobile lab unit. We will eventually have one of those over here, but not here just yet. But we do have a lot of the equipment available. This is the kind of where all the first trial work was carried out in a United Utilities site in Appleby. And there's now a permanent installation on that site. And United Utilities, I might add, they have offered to speak to anybody in the utility side of area to verify all the work that they've done. And they have done reference case studies that have been published on their sites and on LinkedIn and so on. The last site here is actually in Laois Sawmills in Port Laois, where we've installed this XFM10, where ahead of an activated carbon filter, where all of the water it has to be filtered before going off site. The XFM takes out all the solids where you've got sawdust and so on ahead of going into the carbon filter, so that we don't have to backwash the carbon filter. This kind of last photo is this kind of a quirky one. It's United Utilities in Failsworth, where they started with one filter, then another filter, and then they've now built up. They're now in full flow of the site is going through all of these XFM filters. So it's quite a big comprehensive installation. They're not exactly sure yet how they're going to set it out as a final installation. What's likely to happen is that these XFM20s will be replaced by one or two more XFM40s, just to have the whole thing as a tidier installation. But this has all been done because the system has worked so well, and taking a site that has been failing on a whole load of levels and improve it significantly. Applications tend to be either in direct single pass, where you might be taking out of a clarifier or a rainwater harvested at tank, or whatever the source of water might be, single pass through the filter into outlet, or might be multi-pass. So just a few more case study highlights on this. One of the big things that they use these filters for is phosphorus removal. So some of this might be with or without chemical addition. And the factor of that will really depend on what form of phosphorus is within the system. So if you're dealing with orthophosphate, then almost certainly there's still going to be some ferric addition needed in a pre-mixing tank to put a little bit of extra flocculation together. If the phosphorus is just tied up in solids as opposed to being orthophosphate, then it should be fine for it to come out in the filter itself. In this case, you're dealing with phosphate levels, without chemical dosing of around 1.25 milligrams, and with chemical dosing down to 0.04. So that's really good. And you can see the outlet water is absolutely crystal clear. Another site here, they were tankering water off. Literally, all the water coming off site had to be tankered because they couldn't meet any of the limits that they had. You can see the inlet side. There's quite a lot of particulate in it. From the day the XFM was installed, they never had to do any more tankering off site, and you can see there's a fairly nice sludge buildup on that. So that particular site saved a lot of money on tankering. A refinery site where you can see the inlet is absolutely hideous coming off. So a lot of hydrocarbons and everything in that. Outlet water is really clear. And again, in this case, the sludge is so heavy in it that they had to do 2 backwash passes, which is, again, it doesn't take an awful lot of water, an awful lot of time, but you can see that the sludge retention is really good. The technology itself originated out of in the whole swimming pool area, and you can see, here's a case, pre-installation, post-installation, and then with ongoing use, it goes to gin clear water. So you're looking at, it's a very simple system, containerized units, and so on. It's plug and play, pump, gravity feed, very low capex, low opex, and I think kind of the 2 key things are if I was to be asked the biggest benefit of the XFM filters, I would say it's the lack of human intervention that's required in operation, and the other aspect is that the lack of hydraulic loss during operation as well, which makes it a very, very attractive product. So there's loads of ESG benefits, as you can imagine, with chemical reduction, energy efficiency, and so on, which is good. Depending on what you're actually filtering, that sludge, certainly in our cases, the sludge can often go back up to the head of works. Not in leaf sawmills where it goes off site as concentrated hazardous waste, but we do have other installations on water treatment plants where the sludge goes back to the head of work, so they have no sludge going off site. The leaf sawmills site, Leash have very kindly given us full access to their site. The installation is right beside the gate, and they've given us permission to bring anyone onto site to see the installation. You can see we have a 10 cubic meter activated carbon filter. Their site it's about a 5 hectare site, and all the rainwater from the site is run off into an attenuation pond, which is actually underneath that filter, into the attenuation tank. It's about a 300 cubic meter attenuation tank, and we have everything is pumped up through a gross solids filter and into the XFM. When the rainfall is minimal, we put it into dialysis mode, so we're constantly cleaning out the attenuation pond below. When there's times of heavy rainfall, we have it running on full pelt on high flow, where it goes from this into the carbon filter and discharges to river from behind here. And in prolonged periods of dry weather, we simply drain the filters and we leave the system dormant until the next time when there's likely to be rainfall. So it's quite a simple operation, and in this case, its purpose is to remove chemicals that are used for treating timbers. You see some of the fencing posts in the background there. They'd all be treated with tanneless products and so on to extend the life of the timber. And we have that present in the attenuation pond, and there's zero present coming off the carbon filters at the back. So so far that the unit's doing everything it's supposed to do. And because this is only on rainfall, this is being backwashed about once every 4 to 6 weeks, depending on rainfall events. So it's really very, very little human intervention on it at all. It's also worth pointing out that we have trial skids available These are just simple skid units with rotameter and your inlets, sludge outlet. That's now got a sludge pump related to it. The water outlet, sampling points, and so on, available for hire. And the way we do it on hire is if somebody pays for the hire, then that comes off, or a portion of that, depending on what's required, comes off the sale of an eventual unit. But we have two of those units available to go to site to actually have for proof of concept. So it works really nicely. So that's the filtration side of things, and we have that filtration to make our carbon filters work better, because we don't like to clog up our carbon filters with colloidal matter. I could talk about activated carbon for a day, because there's so many different extensive parts of it, but for this we really want to focus on these persistent organic pollutants and PFAS in particular. So just for starters, Puragen, most people are not familiar with the name Puragen because they're probably more used to the names CPL activated carbons, and so on. But since last year, or since late 2024, CPL has been rebranded as Puragen, and since the middle of last year, NovaQ, who've been working with CPL activated carbons for the last 13, 14 years, we just signed a new distribution agreement with them, which now means we're working with them across all areas of activated carbon, mobile filtration, and so on. And we've extensive stocks in Dublin on the back of it. So Puragen is it's a full service provider, which is really important. So it's not just about supplying activated carbon. There's genuinely this is cradle to grave on activated carbon. So from the activated carbon supply, it's the across water, wastewater, vapor phase, and so on. And it's taking that carbon back. Well, it's putting that carbon into filters as required, but then also taking that carbon back into a reactivation process. And the reactivation is incredibly important when it comes to PFAS, because it's part of the destruction process in PFAS. So, what can activated carbon remove? We look at it in two sides. On the organic side, you've got gas phase and liquid phase, and on the inorganic side, where we're generally looking at the need for additional catalysts or impregnants to be added to the carbon. Biggest area for us in that would be for H2S and ammonia removal, but there's a lot more there in terms of solvents and everything as well, for volatile organic compounds, and in liquid phase. Really, as I said, the key thing for today is just to talk about this PFAS removal. So what is PFAS? And it's the PFAS chemicals are they're very much in the headlines now, because the regulations are quickly coming down the track in terms of not so much about the removal of them, but certainly more and more sites are being asked to identify whether or not they have PFAS and persistent organic pollutants within their waste streams. And what we're discovering is that even if we don't have PFAS in processes, that doesn't mean that we don't have PFAS within the waste streams coming out of all kind, whether it be municipal sites or industrial sites or what have you. There are per and polyfluoroalkyl substances. There's over 1,000 compounds that are out there. There's widespread industrial use. What we'd be most familiar with is if you see them in non-stick environments, the chances are you're dealing with some form of PFAS. There's fabric coatings, Gore-Tex and so on. We see them in PTFE for non-stick food surfaces. They literally, there's widespread applications since the 1950s when they were first introduced, and in firefighting foams as well, which means that in places like airports and so on, they're the particularly sensitive areas where these might have been used. They're incredibly stable and they don't break down readily in the environment. But where they do, even their byproducts are also problematic. And so there is this unhelpful term, forever chemicals. And I think every time I do this, or one of us does this presentation on a face-to-face basis in an audience, someone will put their hand up and say, "Well, they're not really forever chemicals because they do break down eventually." But yeah, we do. It's an unhelpful term, but it does kind of set the scene. So, but they are they're known to cause serious health risks, and they are a serious concern at the moment. And the removal of these going down the tracks in future is going to pose a challenge for a lot of industries. So the solution, I mean, where we have this with Puragen, we use the phrase search, capture, and destroy. What does that mean? In terms of search, I suppose when we went back to look at this originally, I mean, talking to the guys, so the technical guys in Puragen, they were saying, well, they thought, well, we'll just go out to the lab and we'll get things tested and see how much PFAS or what PFAS is out there. It was actually very difficult to find the lab capacity to actually do the measurements of what was there in PFAS. So Puragen themselves have built up their own laboratory techniques to support external laboratory techniques for identifying the PFAS compounds. Interestingly, where because of the reactivation facilities that they have now as well, the carbon that's going back for reactivation is being tested for PFAS before it goes into reactivation. And what we're discovering is that PFAS is there in many, many cases. In terms of customer waste, so we are able to take customer waste, identify the PFAS that there, and select the most appropriate carbon for that PFAS removal. So that's new, and that's exciting. So when it comes to the capture, we've developed several surface modified activated carbons, one or two of which are now commercial, which have improved removal efficiency for all PFAS. And then at the end of the process, that carbon can be sent back to the reactivation facilities in Immingham, where they go through the 3-stage process of reactivation and then thermal oxidizer and scrubbers to make sure that even post-reactivation, anything that comes off in that process doesn't get out into the atmosphere. We can cope with very high levels of fast levels, and recycling completely destroys the PFAS. So there's lots of technologies being tested, globally for removal for PFAS, but carbon is considered under US EPA, it's considered best available technology. And particularly now that we've proven that PFAS can be destroyed in the CR1 and CR2 kilns, which are the standard green and amber waste water and standard carbon kilns and advanced scrubbers. So for high concentrations and for testing for background limits. The FiltraPure CH range, which is this modified carbon, is best in class, and it's now commercial scale and running. And there's no new carbon versions coming all the time, but legislation is only coming to the fore now in terms of setting the limits that are needed And there is strong lobbying from the chemical industry at the moment trying to cut back on this whole area. But there's equally strong lobbying from the environmental side about how, where these limits need to be set. So it'll be very interesting now going forward to see what happens in this space. With the surface modified activated carbons, you're dealing with, it's kind of the first range of these. Up to now, it's generally been standard carbon for this application, and we've done a lot of work in comparing these surface modified products to the previous to the standard carbon methods. But what it does, the surface modifications expose the carbon to the PFAS molecules, and it improves the absorption capacity. We've got case studies confirming this, and if you look at in terms of the blue, you have you can see where standard reagglomerated carbon does perform reasonably well on some of the longer chain PFASs, but and some of the shorter chain ones, they struggle. But with the modified carbon, you're getting excellent removal on the long chain PFAS, and even on the shorter chain where the carbon does struggle, you're getting about 3 times more removal with the surface modified carbon. And for water applications, you can improve this by having multiple pass on the activated carbon and so on. You then take the concentrated spent carbon. You can see the levels of PFAS that we have on the spent carbon are really, really high. And on the reactivated carbon, they're eliminated. So we know the reactivation process does eliminate PFAS, but then everyone asks, where does that go? Surely that's just going out with the rest of it. But we've got independent testing to show that the liquid phase emissions from the plant are incredibly low, and the liquid phase is 0, and the stack levels, interesting here, you're looking at 22 nanograms on the stack, which does say, you kind of go, well, 22 nanograms is not great, but when they did a test blank away from the stack, it's still 19 nanograms with a level of uncertainty of 27%. So, this is considered to be a very good result, and this is continually being monitored going forward. So, this is where we're able to use the phrase search, capture, and destroy, because we're capturing the PFAS and we are destroying it in the reactivation process. There are loads of case studies available where this is being done. Given the time, I'm not going to go into these, but needless to say, there's in gas phase, these are high flow VOC 30s, each up to 60,000 cubic meters, so we can high flow, low PFAS levels. These would be soil and groundwater remediation sites. These are all liquid vessels that would be used for taking PFAS out of soil. And here's another remediation site where there's both. You've got gas phase and liquid phase for removal of PFAS, as well as whatever else is in the groundwater contamination. These are all award-winning innovations now, which is really exciting, and we've got the backup of an R&D team and lab facilities within Immingham. Andy Leet, who's the technical director, he really is now becoming quite an expert in this area, and it's great to have his support available to us over here. We're about to start doing some work with one of the universities here on just having a little bit more in-depth analysis on what's happening from an Irish perspective. And there's always ongoing research and development on new surface modifications on the carbons to see, particularly if we can improve the performance at some of those lower chain, lower chain problem areas. The technology itself, we've had lots of awards which we're kind of really happy with, but the one we're most happy with is actually the overall Green Apple Award in 2025. That's a global thing. The lads had to go out to New Zealand for their sins. David Ray there on the left, you'll see he speaks at an awful lot of events, and it's worth following him on LinkedIn. Because he really is, he's kind of the face of Puragen when it comes to this whole side of thing, and his LinkedIn posts are very informative in this area. So just to finish off on this, I've mentioned that reactivation is relevant. From an Irish perspective, reactivation hasn't been that relevant up to now because it's actually been very difficult to remove spent activated carbon from Ireland, because you've got to go through all kinds of TFS approvals because we didn't have TFS in Ireland, but that's now changed. And the reactivation it's really important because from an ESG perspective, most people don't realize is that activated carbon has got quite a heavy carbon footprint. So for every ton of virgin activated carbon, coal-based activated carbon, that's 6.7 tons of CO2 equivalent. Coconut carbon even is still 5.4 tons, and wood is 3.5 tons. But reactivated carbon is only 0.46 tons of CO2 equivalents. So it's from an ESG perspective, if you can use reactivated carbon, not only is it a much cheaper carbon to use, it's from an ESG perspective, it's got a much, much lower carbon footprint. And from an Irish perspective now, we've bought into this, what they call the ReactSys, the cradle to grave, where we've got TFS approval to return spent carbon from Ireland to the Immingham facilities in the UK, and we're now doing this on a, I think in the last in this month we'll probably have two container loads of spent activated carbon going back for reactivation in Immingham, which is really exciting because that's carbon that would before now have either gone to incineration or gone to let's say it has gone to composting and then ultimately landfill. And bear in mind the carbon that's gone to activated carbon that's gone to landfill is contributing to PFAS in the landfill, which is coming out in the waste leachate and the gases it's coming off landfill. And we see that because we're seeing the elevated levels of PFAS coming off the activated carbon that we're using on the landfill gases. So that's the end of my talk, and I am now I'm going to stop sharing again, see how this goes.
Thanks, Julian. I was going to say, you can leave your details up there if you want, if people want to contact you. But again, thanks a million for that. It was very informative on a very pertinent topic as well.